In the circuit shown, both the enhancement mode NMOS transistors have the following characteristics. Kn is equal to mu n Cox W by L equal to 40 microampere per volt square and threshold voltage is 1 volt. Assume that the channel length modulation parameter is 0, which means lambda is 0. And body is shorted to source, which means body effect can be neglected. The minimum supply voltage needed to ensure that transistor M1 operates in saturation mode of operation is dash. So the minimum supply voltage VDD minimum needed to ensure that transistor M1 operates in saturation region. Now let's see here, if M1 operates in saturation region, let's say it takes some current to flow through it, then the same current should be flowing through M2. The moment some current flows through M2, which indicates that the voltage across it is greater than threshold voltage, because diode connected Mosfet is always in saturation region if the voltage across it is greater than threshold voltage. If M1 is going to be in saturation, M2 obviously is also in saturation, the currents flowing through them, as we know, should be equal. We know all the parameters of these two transistors are same, mu Cox W by L and even threshold voltage, which means we can cancel both mu Cox W by L on both sides and even 1 by 2. Then we can write VGS1 minus VTH whole square should be equal to VGS2 minus VTH whole square, which obviously indicates that VGS1 should be equal to VGS2. So we know what is VGS1, which is 2 volts, which means VGS2 should also be 2 volts. But the thing here is, whatever is the VGS value should be equal to VDS also, which is 2 volts. Now as we are asked the minimum voltage required at VDD, which means what is the minimum voltage across M1 to make sure the M1 transistor is in saturation region. The minimum voltage across the M1 transistor VDS1 will be equal to VGS minus VTH. Of course, if VDS1 is greater than VTH, still the transistor is in saturation, but we are asked what is the minimum supply voltage required to ensure M1 operates in saturation region. We know VGS1 is 2 volts, VTH is given as 1 volt. So VDS1, in fact this is the minimum value, is equal to 1 volt. Hence the voltage across M2 is 2 volts, voltage across M1 is 1 volt. So VDD should be equal to 2 volts plus 1 volts, which is 3 volts. So hence the answer is 3.